Hey everybody, this is Dr. B and let's talk about the mole. The mole is just a number. It's a really big number, 6 times 10 to the 23rd. Being that large, it's really too many to count, isn't it? However, we can measure it instead. We could just weigh out or volumetrically come up with that many. Sometimes you don't have to do that for larger objects, right? I mean, consider a donut. Those tend to come in groups of 12, and you can count them out. Consider a sheet of paper. Those tend to come by the ream, which is 500. Now that's probably too many to count. It's easier to weigh it out or to do it by its size. Now let's go down to the atomic level, a hydrogen atom. We can't even see these. It's unlikely we're going to count them, but we can measure them usually by mass. And if you wanted a mole's worth, and that's what we tend to use, you just weigh out a gram. That would be 6 times 10 to the 23rd hydrogen atoms. By the way, note that hydrogen tends to have 1 proton and no neutrons. That's where the 1 gram comes from. Consider an oxygen atom. It's 16 times heavier per atom. So if we wanted a mole's worth, we need 16 grams. By the way, an oxygen atom tends to have 8 protons and 8 neutrons. That's where that number comes from. Let's apply this to a molecule. Water. 2 hydrogens, 1 oxygen. If I needed a mole of water, how many grams of water should I weigh out? 2 H's, 1 O, 18 grams. So imagine a glass of water that weighs 18 grams for the water. That would be a mole of water. If you could see in there, you'd see 6 times 10 to the 23rd water molecules. Okay, now we can do lots of things. Here's some molar masses in addition to the hydrogen and the oxygen, which you already saw. Here's nitrogen, which checks in at 14 grams per mole, and carbon, which is 12. So I'll ask you for a mole of something. You tell me what to do. I need a mole of hydrogen. What should I do? No problem. Weigh out 2 grams of hydrogen. 1 plus 1 makes 2. I need a mole of carbon dioxide. How am I going to do that? Just weigh out 44 grams of CO2. Now I'd like a mole of ammonia. That's 1 nitrogen, 3 hydrogen atoms. Weigh out 17 grams of ammonia. Finally, we can use this for chemical recipes, and this is where the power of the mole really comes in. I need a recipe to make 16 grams of methane. Now, I purposely chose 16 grams because that happens to be a mole of methane. Carbon at 12, 4 hydrogens, 1 each, 16 grams. So, how am I going to do it? Well, I need one of these, and I need 4 hydrogen atoms. So give me a recipe, or what chemists would call an experimental procedure. And that recipe would be something along the lines of taking 12 grams of carbon and 4 grams of hydrogen, and lo and behold, you will make 16 grams or 1 mole of methane. How many molecules of methane is that? 6 times 10 to the 23rd. This is an introduction to the mole.